Welcome to CIACon, an open community of cybersecurity researchers. This is Security Testing with Raspberry Pi, and I am your host, Daniel Dieterle. First, a little bit about me. I started in IT support. Over the years, I supported the servers and networks of hundreds of companies across New York State. I have also worked in large corporate data centers and even an Ivy League school. I've been in the security field for a little over now 10 years as a security researcher, consultant, and author. I am an internationally published security author and currently working on my 7th security book. This talk will be about using IoT devices, mainly Raspberry Pis, in the security field. Kali Linux is one of the most popular distributions for penetration testing and security assessments. It is fairly easy to use, especially if you have Debian Linux experience, and it is loaded with security tools. It is used heavily by pen testers and red teams, and the official certifications for Kali are some of the most coveted certifications by new security personnel. It can be run on a desktop in many different ways. You can install it and run it via USB, directly load it as the main operating system. You could dual boot it with another OS, run it in a virtual machine, use it directly on Windows 10 and the Windows subsystem for Linux, or even in a cloud instance. Virtual machine usage is very popular, as you can quickly set up a pen test learning lab with just Kali Linux and a handful of targets like Metasploitable 3, Windows 10, or Windows Server 2019. But that's not why we're here today. Kali Linux can also run on many ARM-based IoT devices and even Android phones. In this talk, we'll focus on Raspberry Pi. Many would think that these are cut down or reduced versions of Kali Linux, but they aren't. Most ARM-based Kali Linux images contain the entire operating system, and all the standard tools are available for download. Granted, some tools won't run natively on ARM, but most do without any problem at all. So, for a fraction of the price of a full desktop, the Raspberry Pi Zero costs $10. The Raspberry Pi 4 starts at around $35 American dollars. You could have a fully functional security testing system in a small box. Because of the cheap price and the small stealthy size, RPIs are also very popular by pen testers and red teamers, using them as drop boxes. Drop boxes are basically hacker boxes left on a target site during physical security site tests that the pen tester can remote into later and access the target's internal network. You have a lot of capability with using the Pi by itself, but you can also use a ton of add-on devices to further increase the Pi's capabilities. You can also interface with a lot of industry testing tools with the Raspberry Pi. A lot of the Hack 5 devices will work great with an RPI. Common add-on devices are USB Wi-Fi antennas, software-defined radios, Bluetooth and RF scanning devices. There are also a lot of add-on hat devices that plug directly onto the Pi. Devices like screens, or as pictured in this display, an IoT Edge AI computing board that could connect to hundreds of different Grove sensors. We will get to other uses for a Pi in a minute, but first let's talk about running Kali Linux on a Raspberry Pi. To get started, just download the Raspberry Pi ARM image from the Offensive Security website, write the image to a memory card, pop it in, and boot it up. It really is that easy. In a few seconds, you'll see a full Kali Linux graphical desktop on the Pi 4, just as it were a regular desktop computer. You can install Kali Linux on a headless Pi, one that has no video display, and then you just SSH into it to operate it. Or you can hook it up to a regular HDMI monitor, use any of a number of LCD display boards, or use the 7-inch official Raspberry Pi touchscreen display, as seen here. The only difference between regular Kali Linux and the ARM version is that it comes with a limited number of tools installed. This makes it much easier to set up security testing boxes or drop boxes. You only install the tools that you actually need. The Kali Linux tools are available in what are called meta packages. These are tools separated by category names. For example, the wireless meta package has all the wireless tools, the forensics package, all the forensics tools, and so on. This way you can create a customized security testing box that doesn't include unnecessary tools, saving the Pi's precious resources. Once the install is finished and you install any meta packages that you want onto Kali using the apt install command, you have a normal, fully functional Kali install. Everything is there and works exactly the same on the Pi 4 as it does on a desktop system or in a virtual machine. You can scan wireless, enumerate networks, use network and application testing tools, exactly as you would on a normal Kali install. You can also install additional or third-party testing tools on the Pi, basically anything that is compatible with ARM. These include some professional level at-cost pen testing tools, but also hardware tools like RF and Zigbee scanners and all the add-on boards and adapters that we talked about earlier. But I don't want to use Kali Linux. You get this a lot in the field. Some people love Kali, some hate it. And the truth is, you don't really need it. In the Linux world, you can install your favorite security tool on your favorite flavor of Linux. The same is true in the ARM world. Well, kinda. Not every Linux distro has an ARM-compatible version, but you can always just use Raspberry Pi OS, or Raspbian as it used to be called. Raspberry Pi OS actually works really well for the security field, and unlike Kali, it has full support for the traditional Raspberry Pi features, like software to run the Raspberry Pi cameras. It is also very easy to interface with RPI input-output pins using Raspbian, or Raspberry OS. But just from a security standpoint alone, you can apt install many of the security tools from the terminal, and they work perfectly fine. Like this example here, I simply just installed Nmap as I would on Kali Linux or any other Linux distribution, and it works perfectly fine. But what if you have a lot of security tools that you want to install and you don't want to install them one at a time? I actually ran into this question when I was writing my security testing with the Raspberry Pi book, and I found a solution. The Pen Testers Framework is a fully customizable security tool that installs security tools, and it works great on the Raspberry Pi. Well, it works pretty good on the Raspberry Pi. Some of the tools that it installs by default are not ARM compatible. Though, as the Pen Testers Framework is completely customizable, you can configure it to only install the tools that work and the tools that you're going to actually use. When you run PTF, you select the tools you want to install, and then it does its thing. It automatically downloads, compiles if necessary, and installs all the tools that you selected. When it is finished, you have a weaponized Raspberry Pi, all set for your security tests. One of the tools you can install with PTF is Sniper. Sniper is an automated web server scanner and attack tool created by 0 Days. Sniper is fully automated. Just select your command line options and set the target, and Sniper begins to automatically enumerate and scan the target using multiple scanners and web app security tools. If it finds a vulnerability or multiple vulnerabilities, it will automatically attempt to open a remote shell with the target using an exploit. It works equally well against Linux-based and Windows web servers. You can download and use a standard version for free. The professional version is at cost, but has been a go-to tool for many professional pen testers. One pen testing company I know loads up multiple Raspberry Pis with Sniper and leaves them laying around the target company's site when doing the physical access part of their pen test. They can then remotely access and security test through the RPIs. Warberry Pi is another security tool that was developed specifically for the RPI. It also was created for Red Team Dropbox use and was designed to hide on a target network and be as stealthy as possible while it collected data. Warberry analyzes existing traffic and can perform auto-analysis and attack. It has stealth features built in. It can even pretend to be a printer, so it blends into a large network environment. It also has the ability to emulate a MAC address of an existing device, further improving its stealth. Lastly, you can set up a covert 3G channel with Warberry so it can be accessed remotely from anywhere. The Raspberry Pi can also be used as a cybersecurity learning lab or as a target itself to help teach or to learn computer security. RasPwn is an all-in-one security learning lab based on the Raspberry Pi 3. It is loaded with multiple vulnerable web apps and services. The OS runs multiple servers and is designed to run via Wi-Fi, so you can basically have a complete self-contained lab all on one RPI. Just connect to the Raspberry Pi via Wi-Fi and use your favorite pen testing tools to test away. Damn Vulnerable Pi, or DVPi, was another great use for a Raspberry Pi. It is a purposely vulnerable Pi image that you could try to break into, kind of like a CTF challenge. This one worked even better if you had an LCD touchscreen display, as you could interact with the menu buttons on the front of the panel. Basically, you just burned a DVPi image, set up your display, and you had a ready-to-use pen test target. As I mentioned before, not everything that works on Linux will run on ARM. One specific program is Docker. If Docker images don't have ARM support included when they're created, they will not run correctly on a Pi. Though some popular testing tools have been modified so they run correctly on a Raspberry Pi, one example of this is OWASP Juice Shop. Juice Shop is a popular insecure web app that is used in security training, capture the flag competitions, and is a great tool to practice your cybersecurity skills. What's even better is that it runs great on a $35 Raspberry Pi. This was just a quick overview of using Raspberry Pi as both a cybersecurity attack system and as a target. Hopefully I demonstrated that the Pi is very capable for both tasks, and that the price point for a Pi makes it a very attractive platform for the security industry. I go much deeper into all these topics in my book, Security Testing with the Raspberry Pi, available on Amazon.com. Pipioloa by Meme82 is a framework which turns a Raspberry Pi Zero W into a flexible, low-cost platform for pen testing, red teaming, and physical engagements, or into a little offensive appliance. Just burn the image, pop it into the Pi, and power up. Within a few seconds, a new Wi-Fi network will appear. Log into the new Wi-Fi network, open a browser, and surf to the control panel. And that's it. PwnPi is a HID attack device, a hardware interface device attack device. Basically, it acts like a keyboard and mouse when plugged into the target system. If you're familiar with Hack5's Ducky script, the process is very similar, though PwnPi has a lot more capability. To configure PwnPi, you connect it via SSH or through the web interface. You then enter commands that you want the computer to run. Then, when you're ready to use it, you take the Pi, plug it into the target system. PwnPi acts like a keyboard. After it boots up, it automatically begins entering the attack commands, one character at a time. Unlike other HID-type devices, even when the PwnPi is deployed, you can still remote into it and modify or reconfigure it on the fly. Once you configure the PwnPi with the commands that you want it to run, comes the fun part. Deploying it during a pen test or red team engagement. This is where your ninja skills come into play. All you need to do is plug the PwnPi into a target computer and arm it. It will then do whatever you program the device to do. This could be copying documents off of the target system, copying a C2 payload onto the system, scanning the target network, looking for credentials, or even take over the computer and use it to attack other computers on the network. The security tester can remotely connect to the Pi at any time. even when the device is deployed, and can completely modify the device's behavior. It can be reprogrammed on the fly to do an entirely different task than it was programmed to do, all live and in real time. This is the PwnPy Web Control Panel. This is where all the configuration and control for the tool takes place. As previously mentioned, the web interface is a live interface. When you make changes, the changes are effective immediately on the device. The tool creator has done an amazing job with the interface. I was playing around with a lot of the different configurations and put the device in an unstable state. Any other HID type tool would have most likely needed to be unplugged, brought back to the host system and reconfigured. But I was able to redeploy default settings of the device while it was connected to a target system, and I was back in business. Let's take a look at the main menu items. The top left 4 menu buttons are for configuring the different connection types. You can connect to PwnPy through USB, Bluetooth, or Wi-Fi, and these buttons allow you to configure all the settings for that. The next button is Trigger Actions. These are a major part of the new PwnPy version. They really add a lot of intelligent scripting to the tool. There are several pre-existing scripts that tell PwnPy how to behave when it is connected to the target. When you get used to using the tool, you can bring it to the next level by adding your own trigger actions. You can trigger off of several events, including USB connected to the host, Wi-Fi access point is up, DHCP least issued, or even a SSH user login. And these are just some of them. There's several more. And these events can also be set to fire once or multiple times. You can add multiple triggers or modify existing ones. As you can see, with using the combination of settings, you could create a very powerful attack tool. The possible combinations are really only limited to the imagination. The HID script editor is where the magic happens. With the HID script editor, you can create ducky-like scripts that run on the target system. The difference is you can change these scripts on the fly through the remote control interface. This is the programming code used to control the keyboard and the mouse. Any text is sent through the USB port, one character at a time, but at a very high rate of speed. String text is entered with the type command. Notice the /n at the end of the line for the enter key. The rest of the commands are a script to move the mouse around the screen and to change the typing speed or the moving speed. You can make any changes you want on the script, then save it to run on a target system later. Or if the device is already connected to the target and you are remoting in, just click the run button and the script is executed live on the target system. When the program starts, it opens Notepad on the target system and starts sending or typing one character at a time through the USB port. It also controls the mouse movement and the speeds of both. This is just a basic demo program and wouldn't be much use in an actual security test. Though one of the other sample programs called Mouse Jiggler is kind of interesting. It will just randomly move the mouse around the screen at random times. This is something you could use if you wanted to mess with someone's mind. Again, this is just a simple test. There are many PwnPy scripts available online that do different things. You can also enable the device to act like a USB drive, so you can copy files to and from the device during an attack. This is perfect for exfiltrating data from the computer or the network. It is also good for uploading commands that may not be on the device, or malicious programs like a C2 exploit payload. Lastly, let's look at a fun payload that I made for a large red team agency. The target network was being hardened against potential Russian-based hackers. This script would be used on PwnPys, which would be taken by red team testers into the target organization being security tested. If they could successfully access computers in an organization, they would connect the PwnPy to the systems and run this script. When the attack script was triggered, it would cause a computer to speak through PowerShell voice commands saying, "Oh no, it must be a Russian hacker." Then multiple Russian flags would pop up in the web browser windows. The test sample is only 6. I had it set to 100. Lastly, the Russian national anthem would play in a hidden Internet Explorer window and at maximum volume. Silly, I know, but it proves several things. Firstly, that the red team successfully accessed computers in an organization. They were able to run a program on the target system, causing the system to reach out to the internet and play a video, but also to download and open the Russian flag from a red team server. This type of attack actually wasn't my personal idea. Back several years ago, allegedly, U.S. and Israeli hackers infiltrated and made workstations in an Iranian nuclear facility play AC/DC's Thunderstruck at night and at full volume. This was a part of the Stuxnet attack. The music video part of the attack can be replicated very easily with PwnPy using just a very limited amount of code. PwnPy is a very useful and powerful tool. The last topic I want to cover today is some fun uses for the Raspberry Pi and future uses of IoT devices like the Pi in cybersecurity. One of the most popular uses for the little Raspberry Pi Zero W right now is to turn them into a Pwnagotchi. Pwnagotchis are ridiculously cute little Wi-Fi hacking devices. They are just a Pi Zero with an LCD display or an e-ink display, but the magic is in the software. The A2C based AI code powered by BetterCap learns from its surrounding Wi-Fi environment and automatically hacks any Wi-Fi networks in range. Okay, it doesn't really hack them, it just tricks the Wi-Fi network into giving up its authentication handshake as well as any PMK IDs. These keys are then saved to be cracked by Hashcat at a later time. The cool part of a Pwnagotchi, though, is the adorable and lively status faces that it shows during different stages of scanning, detection, and key capture. If you have more than one Pwnagotchi, it makes friends with each Pwnagotchi it detects, sharing information with it. New cybersecurity students love these things, and they are a great tool to learn about Wi-Fi security. Cute interface aside, they are running BetterCap in the background, which is a very good Wi-Fi scanning and attack tool. The problem with Pwnagotchis are that they use the internal Wi-Fi, so the range isn't that great. You have to be fairly close to the target Wi-Fi network for them to work, and you are fairly limited with what else you can do with them once they are running the Pwnagotchi code. But with a little tweaking, you could run it on a Pi 4 with an extended range antenna. Or, with a little more tweaking, you could turn your whole office into a Pwnagotchi playground. Not interested in something that looks like a toy? Then you may want a mini LCD display and some custom programming. This is an automated Wi-Fi scanner I made using a Pi Zero, Adafruit 24x24 LCD display, and an extended range alpha. As soon as you plug the battery in, it automatically begins detecting and scanning Wi-Fi networks using the AirCrack NG toolset. Of course, you don't need to run Wi-Fi attack tools. Being full Kali Linux underneath, you could use your $10 Pi Zero to test web security using Sniper. IoT devices are used heavily in physical security, and the Pi is no exception. A couple different Pi cameras are available and are easy to use and set up. You can use the built-in Raspbi OS commands or use special programs like MotionEye that can turn your cheap little Raspberry Pi into a high-res motion detect surveillance camera. Another option is the Raspberry Pi night vision camera. Software-wise, it works exactly the same as a regular camera. You can swap one for the other without changing any settings. But with the night vision camera, you get full room size night vision. This is a portable night vision system that I made. It is the same Pi tablet that I've shown before, It is just running Raspbian, some custom code, and has the night vision camera taped to the back. But the effect is amazing. Here are two pictures of what it saw in a room that was completely blacked out. You couldn't see anything with the naked eye, but you could easily walk around using the night vision system and see perfectly fine. Notice you can even read the label on the pop bottle. One last fun use of the Raspberry Pi is using them to track airplanes. Using our RTL SDR software-defined radio adapter, you can literally track airplanes. The flight radar software picks up airplane ADS-B signals, which is plane ID, speed, and altitude, and plots them on a Google Map type display in real time. I had about a 50-mile range with mine. You can also upload your data to the main FlightAware website or Flight Radar website and share them with other ADS-B systems. So you could literally track airplanes across the world just using ADS-B monitor systems like this. Lastly, let's take a few minutes and talk about future uses of IoT devices in cybersecurity. This will include some of the work that I've personally been working on. Pentesters and red teams have used Raspberry Pis and other devices like the Hack5 pentesting tools for several years now. Hopefully I've shown it is very easy to take a Raspberry Pi and use it as a device like a Dropbox. But what's next? What does next generation smart IoT offensive security devices look like? What would they be like? Sensors and sensor input have revolutionized maker boards, robotics, and the IoT world. It will do the exact same for next generation drop boxes. Right now, Raspberry Pis loaded with specific pen test tools are left on client sites as remote access drop boxes. They usually connect back to the security testing team through cellular, internet access, or Wi-Fi. Once they are connected to the target network or a network-connected device, they are left to run until they are picked up at the end of the pen test, or until they're discovered. But imagine a Dropbox with more intelligence. Imagine if they only ran when someone was in the room, or when the room was empty, or when the office lights are on or off. What if they only ran when someone was within a few feet of the device, or they turned off for the same reason, or turned on a remote access microphone under the same situations? Maybe the device is to be used on a vehicle or a ship and only turn on when the device is in motion, tracking GPS. It only turns on when the device is at a certain location, possibly giving hackers remote access options inside a secured facility. Better yet, what if the device lay dormant, just waiting and watching until one specific person enters a room, or a group of specific people, maybe those with admin access or access to sensitive data. When the device has correctly ID'd the targets through facial recognition, imagine if it ran specific exploit payloads or scanners when that person was in the room, or those people. All the above and more are possible right now, and the capabilities and stealth options will only increase as time goes on. This is a proof of concept example of a smart Dropbox that could run scans only when someone is in the room or when they get within a certain distance from the device. It is a Raspberry Pi 4 with an Arduino-based AI edge computing hat and an ultrasonic range sensor. You could also use a light level detector or a human presence detector, or all three. The edge computing board handles all the sensor interaction and the processing. If a certain condition is met, it can handle control over to the Raspberry Pi. The screen shows the range sensor running and displaying distances of detected objects. All we need to do is modify the code so that when a certain range level is reached, only 9 centimeters in the demo, but it could be whatever you wanted, it tells the Raspberry Pi to perform an Nmap scan on the network that is attached to the Raspberry Pi. Again, this is just a proof of concept, it could run and perform any security test or do whatever else you want it to do when the range limit is met. For my final example, I want to show how you can easily take the same concept and apply facial recognition to it. By this I mean we can use a Pi camera, the regular one or night vision, and have the Raspberry Pi perform some sort of security test or function only when a certain person or certain people are detected in the room. Using a Raspberry Pi 4 and the Pi camera, you can easily perform facial recognition. With a little coding magic, you can have it perform specific tasks when it detects a certain person. In this case, it kicks off a Wi-Fi scan when it detects my face. The Raspberry Pi isn't the only IoT board being used in computer security. There are many. One of the new up-and-comers that has a lot of possibilities is the Arduino-based WIO Terminal. It is a SAMD51-based all-in-one unit that has an LCD screen, Wi-Fi, Bluetooth, microphone, light sensor, accelerometer, and infrared emitter. It has 2 sensor ports that can connect to any of the several hundred available Grove sensors, or it can hook up to any of the many add-on boards for additional sensor capability. A couple are shown here in the picture. The WIO can function as a standalone unit or connect onto a Raspberry Pi as a hat, lending all of its processing power and sensor capability to the Pi. The unit was made to be a stealthy drop box, as it is the only unit I've ever seen that has a magnet built in, so it will stick to any metal surface. As you can see here, it's actually sticking on the side of a metal cabinet. Lastly, phones could be used as drop boxes or as pen test devices, or even interact with them. A lot of people are familiar now with NetHunter, so I'll only briefly mention this. But basically, NetHunter is a fully functional Kali Linux install on an Android-based phone. Just like the Pi, it is a fully capable Kali Linux install. It also works great with external devices like Wi-Fi and RF scanners, and it even interfaces with or controls other Raspberry Pi drop boxes. And the stealth factors with it is very high because everyone is walking around with their phone out. It draws little to no attention at all. I just wanted to thank everyone for taking the time to listen to my session today. If you'd like to learn a lot more about all the topics I talked about, check out my 3 latest books. I'm also currently working on a new Advanced Security Testing with Kali Linux book that will be out early next year. Thank you and have a great day.